Hi everyone, this is Professor H. Rahman from Agricultural and Food Engineering Department, IIT Kharagpur. I welcome you all to this NPTEL course on traction engineering. This is lecture 21, where I will try to cover the effect of tyre parameters on the tractive performance of a tyre. The concept which will be covered is by varying the depth, varying the diameter, width and stiffness of the tyre, how it is going to affect the tractive performance. Those things will be discussed in this class. Some of the questions which will come to our mind is, do you have sufficient information on tractive performance of tyre that is required so that the vehicle designer or user can balance the cost of providing larger tyres for the vehicles against what is the benefit he is gaining. So, to get this information, we need to study or we need to know what is the effect of varying wheel parameters on tractive performance. So, what diameter or what width of tyre carrying a given load in a given soil condition, beyond which with increase in tyre diameter or with increase in tyre width, there is no further improvement in tractive performance. That means there is minimal improvement in tractive performance. So, to do this kind of exercise or to gather this information, we need to know what is the effect of varying width or varying diameter, so that we can calculate the tractive performance. When I said it is tractive performance, obviously the questions which will come to our mind is, what are the parameters I am going to study? The first parameter is your rolling resistance, the second parameter is your coefficient of traction, and third parameter is a coefficient of gross traction. In fact, coefficient of gross traction is nothing but summation of coefficient of rolling resistance plus coefficient of traction. So, when we are interested in finding out coefficient of rolling resistance, then what are the equations available and how can I utilize these equations? The most important or most commonly used equations nowadays is your Brix's equation, which we discussed in our previous classes, and there the rolling resistance expression has been given as m upon w, which is equal to 1 upon b n plus 0.5 s divided by square root of b n plus 0.04. And Brix's has also given equation for coefficient of gross traction in terms of torque ratio. So, which is given as Q by R W F by that is nothing but tractive gross tractive effort by W, which is equal to 0.88 into 1 minus e to the power minus 0.1 b n into 1 minus e to the power minus 7.5 s plus 0.04. So, knowing these two equations, the third equation, which is nothing but the traction ratio, that can be computed. But in this equation, the important thing is what is B n and how do you calculate B n. As you know, B n is nothing but the mobility number, and mobility number can be calculated if you know the strength of the soil, that is core index, and the tyre section width and the tyre diameter. In fact, tyre diameter has to be derived from tyre section width, knowing the aspect ratio and knowing the aspect ratio. So, first thing is I will try to calculate mobility number, and mobility number is nothing but C I B d by W into 1 plus 5 del by H plus 1 plus 3 B by D. So, here the parameters which are going to affect the mobility number is cone index, then section width, wheel diameter, W is the dynamic weight coming on the wheel, then del by H ratio, B by D ratio. These are the parameters which are going to affect. Now, for a given tire, suppose in the market we have tire sizes starting from 12.428, 13.628, 16.928. So what is the diameter, corresponding diameters? If you know, then we can take one such wheel, and then what is the load coming on the axle, if you know, then we can calculate, and del by h ratio you have to assume as 0.2. So in this class I will try to explain what will happen if I increase B, keeping D and del by h constant, then increasing D, keeping B constant and del by h constant. So how it is going to affect the rolling resistance, that is motion resistance ratio, and the torque or gross traction ratio. Again, in the end I will try to cover by keeping B and D constant, I will try to vary the tire stiffness. Tire stiffness means nothing but the del by h ratio. So usually we take 0.2, but we will vary this and we will see how it is going to affect those traction parameters. So what I have done is I have taken a 13.628 tire, is a bias ply tire, which will give you a diameter roughly around 1.27 meter, and the section width is 0.345 meter, and for a wheel slip of 10% and del by h of 0.2, I tried to vary the diameter. So I varied the diameter starting from 1 meter to 2.4 meter. And this exercise was carried out for 3 different soil conditions. As I said, soil condition is represented by Ci, and Ci is nothing but 1000 kilopascal, which is corresponding to hard soil. Ci 500 means 500 kilopascal means it corresponds to medium soil, and Ci 250 kilopascal means it corresponds to soft soil. So these are the 3 typical soil conditions, and there I will try to see how the COT is varying. And COT was calculated, as I said in the beginning in the previous slide. COT is nothing but mu, and this is the formula which will be used, and taking this I have calculated and then plotted. So these are the 3 curves which I got. The black one is corresponding to Ci of 1000 kilopascal, and the orange one is corresponding to 500 kilopascal, and the blue one corresponds to 250 pascal. So in all these 3 cases, what you can observe is by increasing the diameter from 1 to 2.4 meter, there is increase in coefficient of traction. But the rate of increase is less in hard soil and more in soft soil, and medium soil is in between, lying in between. So that means there is a benefit, but that benefit is reduced after 2 meter. If you go beyond 2 meter in soft soil, there is not much increase. If you go beyond 1.8 meter, there is no increase in case of medium soil, and in case of hard soil, after 1.6 meter, 1.7 meter, there is not much gain in coefficient of traction. Now, next thing is the COT, how it is varying with width, tire width. So here what we have done is we kept the wheel diameter as 1.27 meter, and then we vary the section width starting from 0.25 to 0.5. And this exercise was carried out for 3 different soil conditions again: hard soil, medium soil and soft soil. And what we observed is COT in all these 3 conditions were increasing. The increase is more in case of soft soil, whereas it is very minimal in case of hard soil, and the medium soil is lying in between. So that means there is a benefit in increasing the tire width, but beyond 0.4 meter in case of hard soil or in case of a medium soil, there is not much gain, and in case of soft soil, even increasing the width to 0.5 meter has some benefit. So, in all these two cases I have kept del by H ratio as 0.2. Let us now see how the coefficient of rolling resistance is affected, because only coefficient of traction will not help you. We have to also see what is the effect of this tire diameter and tire section width on coefficient of rolling resistance. So, the left side figure, what I have done is I have taken diameter as 1.32, then varied the I have taken section width as 0.345 meter and then varied the diameter from 1 to 2.4 meter, and keeping del by H constant, that is 0.2, and the weight coming on the axle I have taken as 750 kilonewton, 7.5 kilonewton. So, the reason is in a two-wheel drive tractor the normal weight is 2400 kg. So, that taking 65%, 35% weight distribution and static condition, we come to a value of 7.5 on each of the rear wheels. Now, what we observed here is again coefficient of rolling resistance is decreasing for the three soil conditions: soft, medium and hard, when we increase the diameter from 1 meter to 2.4 meter. But the rate of decrease is more in case of soft soil as compared to hard soil. No doubt there is decrease in coefficient of rolling resistance, but the rate of decrease is reducing with increase in soil strength. That means, from soft soil to hard soil, if we move, the rate of decrease is reduced. Similar exercise we have carried out for tire section width. That means, I have kept diameter as 1.27 meter, diameter I have taken 1.27, del by H as 0.2, and then varied the section width from 0.25 to 0.5 meter. And this exercise was carried out taking into consideration the soil conditions. Soil condition means the CI value I changed to 1000 kilopascal, then 500 kilopascal and 250 kilopascal. So, if you look at this figure, you can see there is a reduction. Reduction is more in soft soil, and it is medium in 500 kilopascal cone index soil, and in the rate of decrease is less in case of 250 kilopascal. That means in case of 1000 kilopascal. So, in hard soil again the gain is a little lesser as compared to your soft soil. So, these are the two parameters. Then the third most important parameter is stiffness, tire stiffness. Usually the tire stiffness is expressed as del by H ratio. More softer the tire, there will be more deflection. Harder the tire, deflection is less. So, that is why del is taken as this indication for tire stiffness. So, del by H ratio you have taken. So, this tire stiffness is nothing but del by H ratio, del by H ratio. So, in this Briggs equation, while calculating the mobility number, we keep the diameter as 1.327 meter and section width of the tire as 0.345 meter, and only we vary del by H starting from 0.18 to 0.445. And this exercise was carried out for three different soil conditions: 1000 kilopascal, 500 kilopascal and 250 kilopascal. So, what we observed is in case of hard soil, the lowest curve we can see the rate of decrease in coefficient of rolling resistance is very minimal, you can say. At 0.18 it was 0.061, at 0.4 you can see it was even 0.058, like that. Whereas in case of medium soil, the rate is little higher, that means rate of decrease in rolling resistance is little higher as compared to hard soil. Now, in case of soft soil, yes, we are getting maximum benefit. That means if you go on increasing the del by H ratio beyond 0.4, still it is decreasing. So, there is a substantial benefit which can be obtained in soft soil if you increase the tyre stiffness. Now, if you look at the right side figure where I have indicated the COT value, coefficient of traction value, how it is varying with tyre stiffness. So, again tyre stiffness I have varied from say 0.18 to 0.446, and then for 3 different soil conditions I tried to carry out using the Bix's equation what is the value of COT. Now, what you observe now, you are getting maximum value of COT when the soil is hard, but by varying the stiffness from 0.18 to 0.3 or 0.32, after that there is no gain, almost constant. Whereas in case of a medium soil, the increase in COT is still continuing beyond 0.4, up to 0.4, 0.41, still you are getting benefit. And in soft soil, even beyond 0.46 also, that means when the del by H ratio value is beyond 0.46, still we are getting some benefit. So, let us now put in a tabular form what is the benefit which you get when we try to increase the B value, when you try to increase the D value, when you try to increase the stiffness. All those things are summarized in this table. So, let me go through this the table. In the first case, this is referring to coefficient of rolling resistance. So, coefficient of rolling resistance, how it is changing. When you are keeping B fixed, that means section width fixed, del by H ratio fixed, and only varied the diameter from 1 to 1.8 meter, then the reduction in coefficient of rolling resistance in hard soil is only 21.64%, and in medium soil it is 30.4%, and in soft soil it is 38.68. That means maximum reduction is possible in soft soil and minimum reduction is possible in hard soil. In the second case, I kept D, that is diameter, as 1.22 meter, and then vary section width from 0.3 to 0.45, keeping del by H ratio as 0.2. So, what I observed is there is a reduction in coefficient of rolling resistance. It was only 7.22%, and in medium soil 9.72%, and in hard soil 13.04%. So, that means as compared to B and D, there is more reduction in increasing D as compared to B. So, if you look at this 30.4, 9.72, 38.68, 13.04. So, there is more benefit in increasing the diameter rather than increasing the section width. Now, the third component which we varied is del by H ratio, where I kept this section width as 0.34 meter and diameter as 1.22 meter, and then what I observed is there is a reduction in coefficient of rolling resistance in hard soil as well as medium soil and soft soil. Hard soil, the reduction is 13.61%, in medium soil the reduction is 17.45%, and in soft soil it is only 23.27. So, that means there is a benefit in increasing del by H ratio, but the benefit is more in case of soft soil as compared to hard soil. So, this is one part of the story, that means only coefficient of rolling resistance we have observed. Similar exercise also we carried out for coefficient of traction, and coefficient of traction what we observed is by keeping B constant varying and del by H constant as 0.2 and varying D from 1 to 1.8 meter, we can see the change in coefficient of traction. It is only, there is an increase is only 4.62%, whereas the increase in case of soft soil is 26.08%. So, there is an increase, but the increase is more in soft soil. Now, by keeping D constant, del by H constant, we varied B from 0.3 to 0.45 meter, and what we observed is there is an increase of 1.38% in hard soil. That means there is there is no much gain, 1.38 is no gain, but there is certain amount of gain, like very minimal gain in coefficient of traction, that is around 6.1%, and in soft soil it is around 19%. And keeping B as 0.34 meter, diameter as 1.22 meter, when I increase the del by H ratio from 0.18 to 0.46, again in hard soil the increase in coefficient of traction is only 1.86%, it is very minimal, and in medium soil it was 7.63%, and in hard soil in soft soil it is 29.59%. So, the benefit, if you want to really gain, then increasing diameter or increasing section width or increasing del by H ratio, the benefit is more in case of soft soil as compared to hard soil. As usual, whatever you observed in case of coefficient of rolling resistance, the diameter has more influence in reducing coefficient of rolling resistance. Similar observations also we got in case of coefficient of traction. Here you can again see the reduction is 26% as compared to increase in B, it was only 19%. And del by H ratio, that is giving very high value, 29%. So, what we observed from these calculations based on Brick's equation is there is a benefit in increasing these tyre parameters, but the benefit is mostly gained in case of soft soil, and in case of hard soil there is no much gain. And if your tractor is spending most of the time in medium to soft soil, there is a possibility that yes, we can go for increasing the tyre diameter rather than increasing the section width. And in addition to tyre diameter, if you can increase the del by H ratio to say 0.4, then the benefit will be still better. We have to calculate the rear axle dynamic weight, then based on that and using Brick's equation, you have to find out different traction parameters like COT, CRR, then tractive efficiency, then you have to calculate from COT what is the pull available, and then what is the draft required by the implement. So, once all these parameters are calculated, next thing is the dynamic weight which is coming at the rear axle, and half of that will come on each of the wheels. So, the dynamic load on the tyre, whether it exceeds the maximum load carrying ability of the tyre, that condition has to be checked. If it is yes, then the tractor is not suitable for tractor. I can straightway reject this size of tractor. If it is no, then the next is whether the weight on the front axle is more than 20% of the total weight or not. This will help you in steering. That means front wheel weight utilization factor. This much of weight is required, minimum weight for easy steering. If this condition is no, if weight on the front axle is not more than 20%, then we have to say that the tyre is not suitable for the tractor to operate in these given conditions. Then what you have to do is you have to add ballast. That means you have to add weight. Once you add weight, again we have to go back to check whether the total weight coming in the wheel is lesser than the load carrying ability of the tyre or not. If no, then again we check the weight, whether the weight on the front axle is more than 20% or not. If those conditions are satisfied, then we have to go for checking whether the pool which is developed by the tractor, keeping a power reserve of 50% is equal to the draft which is required by the tillage implement. In our case, it is a motorboat plow. And once this condition is satisfied, that the next check is that the pool should be available at less than equal to 20% of the wheel slip. That is important. If wheel slip is more than 20%, then it is not recommended. So, we have to say that the tyre is not suitable for the tractor to operate at the given condition. So, to reduce slip, again we add weight, and again the same exercise will be carried out. Then that means you are going back to again check whether the tyre is able to carry this load or not, then the front axle weight, all these checkings. If it is satisfied, then we go for saying that the tyre is suitable. If these three conditions are satisfied, then the tyre is suitable for the tractor to operate. That means pool is greater than the pool required, and wheel slip is less than 20%, and the front wheel utilization, front wheel weight utilization factor is more than 20%. So, we go for we can say that the tyre is suitable for the tractor to operate in these conditions, and then we compute COT, tractive performance, and cost. So, there could be a possibility that 2-3 tyres may satisfy this operating requirement, like whatever conditions we have imposed. So, in that case, we have to find out the least cost of the tyre, and which is satisfying these conditions. So, that tyre can be selected. If you are getting little benefit by paying some slightest increase in price, then that is also preferred. So, the main thing is the technical requirement which we discussed, those parameters has to be satisfied. So, in this way we can carry out selection of tyre, okay, and what you can summarize here is the Brix's equation, it is the ACB draft equation, and the front weight utilization factor, and the wheel slip. These are the 4 factors which will control how to select a tyre for a given soil conditions and operating condition. Thank you.